In the previous videos, we have learned about how to find a square root of a perfect square, and some of these perfect squares are a very large number. And in this section, we are going to learn about how to find a square root of a decimal number. But even before we learn on the method on how to find the square root of decimal number, let's observe and study the square of decimal number. So I'm going to pick up 4 decimal numbers here, square it, and let's see whether or not we can observe any similarities between the number and its squares. So I'm going to pick up 4 numbers. The first one is 0.5 squared. 0.5 squared is equal to 0.25. The second number is going to be 0.13 squared, and this is equal to 0.0169. The third one, 1.226 squared, that is equal to 1.5030076, and the last one is 1.3668 squared, and this is equal to 1.86814224. Okay, observe these numbers carefully and write down your observations. You might want to pause this video and take a look at these numbers, or you might also want to write down this number on a piece of paper. So write down, what can you see? What are the striking similarities or the patterns that we want to make use of in going through this lesson? So I take it that you have already done your observation and write them down. So now let's go and take a look at these together. So what is the first observation that you can write down? Yes, let's compare the number of decimal places between the left number and the right number. This is going to be the first very important observation. As you can see, the number of decimal places has doubled when you square it. On the first line here, we have only 1 digit after the decimal point, and here we have 2 digits. Here we have 2 digits before or after decimal point, and here is 4 digits, here 3 digits, and over here 6 digits, 4 digits versus 8 digits. So that is the first observation. The number of digits after decimal point double after you square it. So let's write it down. Our first observation. Okay, the number of digits after decimal point is double. Okay, let me just correct that spelling. Double after squaring it. What is the second observation? Second observation would be to take a look at the last digit of both numbers. Take a look at this versus this, and this versus this, this versus this, and this versus this. What can you observe there? Let's just pick the last digit and square it. The last digit of the left side of the number is 5, and 5 squared is 25. Observe the digits. Okay, the second line, 3. I'm just taking the last digit here after decimal point. 3 squared is equal to 9. And compare again the last digit. They are the same. Now take a look at the third line. The last digit of the left hand side is 6, and 6 squared is 36. And the last digit again are consistent. And on the fourth line, 8 8 squared is 64. Again, observe the last digit. They are again consistent. So our second observation is going to be the last digit of the squared number is equal to the last digit of the square of the last digit. Okay, I hope you get that statement. Well, we have already illustrated what I mean by that. And what about the next observation that you can note down? The third observation is that the square of the decimal number can only contain even number of digits of the decimal number, of the decimal point. Even number, yeah? Take a look at this. This has 2 decimal number, this has 4, this has 6, and this has 8. So a square of a decimal cannot have an odd number of decimal digits of the decimal point. The number of digits after decimal point of a squared number is even. And also, linking back to the first observation, we must also note down that so the last digit of a squared decimal can only be 1, 4, 9, 6, 5. And then if we take 6 squared, it's going to be 6 again. 7 squared is going to be 9 here. 8 squared is going to be 4. And 9 squared is going to be 1. So if you find that the last digit of the decimal point is 2, 3, and what else? 7, 8, then most likely the square root of that number is an irrational number. It is not something that is easily be converged or easily can be found using division method. So now let's take a look at examples in the next video.